Welcome to Q&A Wire.
So we are to calculate the pH of the mixture of 35 ml sample of 0.15 molar acetic acid with these volumes of 0.15 molar sodium hydroxide. So to start with, the first one here, 0 ml of the sodium hydroxide. So we have 35 ml of 0.15 molar acetic acid. So here we didn't add any sodium hydroxide, so we only have the acetic acid. And having only the acetic acid, we know the concentration already, so we can just go ahead and calculate the pH, and that will be negative logarithm of the 0.15, and that's 0.82. Okay, and B is we have 17.5 mil of the sodium hydroxide. Okay, so here it's a little bit different because now we need to know how the reaction happened. So we have acetic acid reacting with sodium hydroxide. We'll have a formation of the sodium acetate and water, right? So the stoichiometry for the reaction is 1:1. Okay, so here we have the concentration of the sodium hydroxide to be 0.15 molar. So we can determine the number of mole of this. So this should be 17.5 divided by 1000 because we're trying to make this in liters, multiplied by 0.15 molar. So that will give us a number of mole. So this is 17.5 divided by 1000. So this is 0.002625 mole. That is the number of moles of sodium hydroxide here. So we have 0.002625 mole of NaOH. Then we have 35.0 ml of 0.15 molar acetic acid. So we're going to do the same thing, 35 divided by 1000 multiplied by 0.15 molar will give us the number of mole of acetic acid. So that's going to be 35 divided by 1000 times 0.15, and that is 0.00525 mole. And we can see right from here that we have more number of mole of acetic acid than the sodium hydroxide. So that means we're going to have excess of the acetic acid by this amount, 0.00525 minus 0.002625. So that will be 0.002625 more. So we have twice acetic acid, twice the size of sodium hydroxide in acetic acid. So this is the excess of the acetic acid. So now to calculate the concentration of acetic acid, we'll have to divide this 0.002625 mole by the total volume. So we have 35 ml of the acid, then we added 34.5 ml, let's see, 35, 17 point, we added 17.5 ml of the sodium hydroxide. Then we have to divide by 1000 to make everything in liters. Okay, just remove this. So what would this give us? divided by 35 plus 17.5 divided by 1000. So this is 0.05. That's the concentration of acetic acid. So then this is in molar. So then pH is a negative logarithm of CH3COOH concentration, and that will be negative log of 0.05, and pH then will be equals to 1.3. Okay, so the next one is we have C, that's 34.5 mil of the sodium hydroxide, and the concentration is 0.150. Okay, so the number of mole here is going to be 34.5 divided by 1000, that's in liters, multiplied by 0.15 molar. That will be 0.005175 molar. And we know from previous calculation that we have 0.00525 mole of acetic acid. So acetic acid is 0.00525 mole. So we still have more acetic acid than the sodium hydroxide. So we have excess of acetic acid. So excess acetic acid will be 0.00525 mole minus 0.005175 mole. And that will be 0.000075 mole. Okay, so we can find the concentration of the acetic acid by dividing the 0.000075 mole by the total volume. So that's going to be 35 plus 34.5 divided by 1000. And that will give us 0.00108 molar. Then pH, which is a negative logarithm of the CH3COOH concentration, will be negative logarithm of the 0.00108. So pH here will be equals to 2.97. And then you just do the same thing for every other one and follow the same procedure, and that's the answer.